We are back once again. It is day 206. Yesterday, I realized I was the chosen heap slayer. I am Heaplon Musk because we have become one with the heap. And it's pretty crazy. So, yeah. That yesterday, we wrote a heap. It took us about 2 hours to write a heap. And I thought it made no sense. And then at the end, I'm like, okay, let's just pump this out. And then I write it at the end, and it actually does work. This is why we do LeetCode. This is why we do it every day. I started that session, and I literally said, I feel like I'm at the end of the session, and I've already started because my brain is fried. But some of the best sessions are like this anyway. So we did it anyway, and it was a really good session. And that's like the whole point of sturgling through. So there's been like 3 out of the 200 days, there's been like 3 days like that where we just had such a good session that it just reaffirmed like this is it. And yeah, I think that way it's just a different sort of, it doesn't feel like dopamine. I mean, I'm sure it all is because dopamine is the molecule for action and stuff like that, but it was much more reflective. It was more like nice. And so that stuff is usually just a little bit more longer lasting for me usually. And it's just to feel strong, man. This is the reason why it's worth it to push a little bit every day. Hopefully we can reap a similar benefit later on in terms of other things. I'd love to learn a lot of other technologies and tools to make my job simpler. And also, it'll make it easier for me to make other stuff. But I tend to be a learner by necessity. And I don't always tend to learn when I actually, yeah, I guess sometimes I am a learner by necessity. I'm usually like I'll figure it out with little tools that I have. But fortunately, we have some comments that are going to help us stall before we have to start. And if we take a look, let me see. We have a comment from RBD Trades. Legendary entrepreneur, visionary author, and just released a new book. You're going to want to check it out. LMA, dude, I love the title. Heaps are one of my fave data structures. Let's go! Let's go! I thought of that title and I thought I had a brain blast. Heaplon, me and Heaplon were actually in the VC last night, and we have some big plans for, there's some big plans coming up for Tesla, so you might want to stick around and join the Discord for that. Appreciate the comment from Wilderness, legendary commenter, as well as legendary profile picture. Context switching, rubber banding is known to lower IQ points by 15 and cause similar effects to smoking cannabis and staying up all night. Is this true? I can't actually tell if this is true or not, but it seems like it's true. It seems like it's definitely true. Yeah, there's definitely associated cost for context switching that is often not mentioned, especially with work. When you're switching around between task 1 and task 2 and then task 1 and task 3, when you're knee deep in task 1, it's just easier to finish task 1 than go to task 2. But rubber banding or context switching is the worst. Sorry if I'm spamming, but I've never heard someone else investigate their mental state so thoroughly before. You are never spamming, brother. Any comment to help stall is always awesome. We're not stalling, but in a way we are. It's just a little pre. I actually have to know, is that true? That's funny. But I have to be honest, I'm tired out of my mind. For some reason, we're doing it anyway. But today's Friday and it's a shorter session, so we'll be able to get through it. It's going to be a lot. Usually we do 30 minutes. We're strapped for time. It's going to be 24 minutes. And we're just going to jump into it. At the same time, if this is something you're interested in, you should join the LeetCode Discord, the Hyperbolic Coding Chamber. It's a chamber designed to help you become the Leet master that you are. So you should definitely join if that's something you're interested in. At the same time, we're jumping back into it. I'm gonna keep it a stack 1,000. I do not have the brain power to ingest more heap stuff. So we're just gonna do another random problem or a couple, and then we're gonna go back tomorrow into the heap with a fresh brain because my brain is fried and we have a long day of work ahead. So yeah, that being the case, We're gonna do a nice little session here. A nice little short session. And I won't waste too much time because we're strapped for time. But benefits of doing it every day. So we can't always. Oh, I forgot to update yesterday's problems with the problems we actually did yesterday. Because we did maximum nesting parentheses. So let's see if we can make sense of this one. So we have something here. You are given an n by n integer matrix grid. This problem is a little involved, I can already tell. You are given an n by n integer matrix grid. Generate an integer matrix. So you have an n by n integer matrix grid. You need to generate an integer matrix of similar probability size. Integer matrix max local of size n minus 2 times n minus 2, such that max local sub I sub j is equal to the largest value of the 3 by 3 matrix and grid centered around the row I plus 1 and column plus 1. In other words, we want to find the largest value in every 3 by 3 continuous matrix in the grid. Return the generated matrix. So it looks like the matrix is actually we're like almost cutting it in fourths here, and then I guess we would have 8 as the largest number here, and then 6 as the largest number in here. This doesn't seem too bad. You'd have 9, 9. The diagram above shows the original matrix and the generated matrix. Notice that each value in the generated matrix corresponds to the largest value of a contiguous 3 by 3 matrix in grid. It feels like we're just, I think maybe this is what they're saying. It's going to be of size n minus 2 times n minus 2. So we're not fourthing it. We're really just subtracting one row and one column from the outside of both. And this is because we have to be within the range to guarantee that we always have a surrounding of 3. To guarantee we have a surrounding of 3, it must be that n's minimum value is 4. Oh no, I guess it could be 3. Right, if it's 3, then we just return a singular value. So if the matrix looks like this, we would literally just return one value. I think we could do this. It looks like we're just going to be iterating within this range here. If we iterate within that range, once we finish the work of finding the max within that range, we could just push the value onto the output. How do we know when to go to the next row? I guess we could just pre-fill it. If that's the case, I think this could work, but something seems a little too simple about this. I guess it's easy, so maybe it's fine. is the equal to the largest value of the 3 by 3 matrix in grid centered around row I plus 1 and column J plus 1. Okay. I'm thinking this could break down to I'm thinking this could break down to iterate through matrix -1 row and column, generate matrix, generate the output. If we generate the output, we would have to make sure that we add a new row. We have to add a new row if it doesn't already exist, that we can add values to that column. And we should be able to do that. So I just wanted to think ahead a little bit to see if we would get caught by anything. And it looks like we can safely just iterate in between. The matrix is a square. So I think we might be safe here. And instead of starting with row 0, right, we're going to say grid.length -1. We're just going to start at col sub 1, right, and then also subtract 1 from the end, so that we pretty much only go in between the center here. Right, but then we're going to have a tuple of x and y offsets. These x and y offsets are going to be used to calculate, and we actually don't need this in the loop. These are going to be used to calculate the offsets such that we can calculate the 6 surrounding values, right? The first value is going to be behind the number, so if we have 1 here, we want to check behind it. That would be row, right? So we'd say -1, 0, right? Now we want to go above that, so that would be -1, right? -1 to go up, back left 1, right, once, right? And then up once. We would subtract 1, not add 1. To go above there, we would subtract nothing, right, and simply subtract 1 to get the number directly above us, right? To get the number to the diagonal of us, we could add 1, right, and subtract 1. If we add 1 and subtract 1, we get this diagonal, right? To get the number directly in front of us, we would simply add 1 to x, add nothing to y. To get the number to the bottom diagonal, we would add 1, right, and add 1 again. To get the number directly below us, we would add nothing, add 1, and to get the number to the diagonal behind us, I guess it's hard to say which one it would be because the cursor doesn't show, but we would subtract 1 and add 1. So I think this should make sense. We should have 1, 2, 3, 4, 5, 6, 7, 8. We should have 8 total values. And we do. And what did they want? The max? So we'll let local max. We're going to let local max, right? We're also going to have to set up a couple bit of things. We're going to let set up our output, which is going to be an array of numbers. And similarly, this is what we're going to return. And then from here, the other important thing is that every time we end up in a new row, we have to check, right, if output, right, if that row doesn't exist, right, then we want to say output.push an empty array so that we actually have access to something we can push, right? Then we're going to let the local max equal grid sub row sub call, and then we're going to do for const x offset y offset of locations. We're going to let the value, right, if it exists, and I have to be honest, I'm pretty sure it's always going to exist because the minimum end value is 3, which means it should always exist. So we should just be able to say local max is equal to the math dot max of local max and grid sub row plus x offset sub call plus y offset. Then we can say output sub row dot push local max. I feel like this should work. Just to be safe, let's run it through a simple example. We have this row here. We're going to start with row sub 1, right, which would be this row right here, as well as call sub 1, which is starting with this 6 here. We're going to let local max to a grid sub row sub call, which would be 6. And then we're going to iterate through all our offsets, which should give us the numbers surrounding it. Which should give us the numbers surrounding it. And then we're just pretty much taking the max. Of all the numbers. So if we say grid sub row plus x offset, so we have row 1 plus -1 would give us row 0, which would give us 9 so far, plus call plus y offset, which is 0, should give us 9, right? Then up 1 back should give us 9, right? 0, this is off. 0, -1. Oh, no, I messed up, right? If we just subtracting 1 from the, I think I messed up. If we're subtracting 1, -1, right, on the x, it's gonna give us 5, right? And then if we say -1, it should give us 9. If we say 0, -1, right, this would actually not give us the 9 up here. Actually, it would. What am I saying? 0, -1 with the y offset up here. Then we'd add 1 and subtract 1 from the y to get 8. We'd add 1, add nothing to 0 to get 2. We'd add nothing. Oh yeah, we'd add 1, right, and then add 1 again in the y offset to get 6. We'd add nothing to the x offset, and then we have the same value. Add 1 to the y offset to get 2. And we'd subtract 1 to get 5, and then add 1 to get 8. Something is really bothering me about locations, but And we're going to want to subtract row by 1 when we insert it. Somehow this works out. So it looks like this would take, we're going to do 6 operations for every number, but we pretty much have to visit every number in the matrix subtracted by the top row, the bottom row, the left column, and the rightmost column, which is basically n by n time with constant space if we exclude the output. If we exclude the output, we're going to do 6 operations for every element. We usually drop the constant, so it would be n minus, well, we would drop the subtraction constants, which would be n minus 2. So it's really just n minus 1. Row minus, so I think it would be linear time. I'm sure there's a way to do this in a better way where you reuse the values, but there's no follow-up. And so I think we'll take that one as it is. So we have check if one string swap can make strings equal. Oh, we have done this before. This is the same problem that we loaded up twice. So we have find, let me just refresh this page. Long pressed name, number of arithmetic triplets. So given an m by n matrix query which is sorted in non-increasing order, if it's sorted in non-increasing order, it means it's sorted in decreasing order with values that can also be duplicated. Both row-wise and column-wise. That's pretty cool. Return the number of negative numbers in grid. Can't you just count all the negative numbers? Oh, could you find an n plus m solution? So I guess first we'll do the regular solution where you just count. Return CT, you'll say row plus plus. Subcall is less than 0, CT plus equals 1. This would be n by n time, n by m by n time. Could you implement n plus m solutions? That means we would go through means we would go through the matrix just once, column-wise, and once, row-wise. How does that make sense? How does that make sense? Once, column-wise. Sorted in decreasing order. Maybe all the negative numbers are connected in some sort of grid. For example, if we were to paste this, which is what we see here, and then gridify it. I can't even read this because the numbers are so close together. I think this is the answer. It feels like because it's both ordered in decreasing order, both column-wise and lengthwise, it seems like if there does indeed exist a negative number, it must start at the bottom rightmost corner of the matrix. For which we could do some DFS style nonsense and just visit all of our nearest neighbors. That should give us that wouldn't be n plus n time though, because if the negative numbers all throughout, it would be n plus n. We'll come back to this, but we'll probably come back to the heaps first tomorrow, so we got a jet.